Module 13.4, factoring the sum and difference of cubes. So one of the reasons why I asked you to keep on memorizing the perfect square binomial is we can use it here. You see, for the sum of cubes or the difference of cubes, the second parenthesis, a squared minus ab plus b squared, that look a lot like perfect square binomial. Okay, almost identical except the two parts. Okay, so if you already have perfect square binomial memorized, then when it comes to factoring sum and difference of cube, it will be very easy. All right, so how do I know the problem I'm dealing with is sum or difference of cube? What you're gonna see is two terms. Both terms are perfectly cubed. All right, one is positive, one is negative. Okay, so for our two types, so my answer will always look like this. So basically, what's going to happen here, in the first parenthesis will be my a plus b. Okay, so these two signs will always be the same. All right. The next parenthesis will always be a squared minus ab plus b squared. So this sign behind the a squared in the second parenthesis is always going to be opposite to the first sign. Okay, that's how we're actually memorizing what the sign need to be. Right? The first parenthesis is going to be the same sign as the problem. The first sign in the second parenthesis is always opposite of what's in the first parenthesis. The last term is always going to be positive. Okay. So there's really no other way to do this except by purely just go by the formula. Okay. Pure memorization. So here I got two terms. Both terms are perfectly cubed. This is addition. This is a sum of two cubes. So let's think about this. A plus B. You know what? I'm going to copy and paste this real quick. I'm going to put my formula up against it. All right. I'm going to do one right here for the minus. All right, let's take a look. All right, so let's match it up. Okay, so a to the third plus b to the third. Okay, so think about this. My answer need to look like a plus b times a squared minus ab plus b squared. So we got to first figure out what's my a and what's my b. So what was my a? In other words, what was this x to the third before it was ever cubed? Before it was ever cubed, it must be x. Okay, so this is basically written as a power rule. So that must be my a. Plus, what was 64y to the third before it was ever cubed? So it must be 4, okay, y. So 4y got to be my b. All right. Oh, but let me write this down just in case I never mentioned this. So perfect cube number. 1 to the third is always 1. 2 to the third is 8. 3 to the third is 27. 4 to the third is the same as 8 squared, which is 64. The only way we know the difference between either 4 to the third or 8 squared is go by the exponent on the variable. 5 to the third is 215, and 6 to the third, I think, is, Lord, I don't forgot. 6 times 6 times 6. 2, oh, Lord, what was it? 6 times 6 times 6. Oh, 216. 125. I was wondering. Okay, 5 to the third is 125. Sorry about that. 125. 6 to the third is 216. Okay, these are the common one we run across. All right, so my a must be x plus my b must be 4y. All right, times my a got to be squared, so x got to be squared, which is x squared, minus a times 3, my x times by 4y is 4xy, plus my b, 4y, whole thing squared, well, that would be 16y squared. And that's it. This is my answer. So once you recognize you have a sum and difference of cubes, then the next thing we got to do is figure out what was my a before it was cubed, what was my b before it was cubed. Right, now this example, 2764, so this must be the subtraction one. So let me do it down here a little bit. I got a little bit of space right here. All right. What's my A? In other words, what was 27x to the third before it was ever cubed? It must be 3x. Minus, what was 64 before it was ever cubed? Must be 4. So that's my A, that's my B, times. Okay, if this is minus, the next sign is positive. My A squared, not 3x whole thing squared, is 9x squared, plus A times B, which is 12x, plus my B 4 whole thing squared is 16. So that's the answer right there. All right, I believe this one has it looked like sum of cube, but not quite, because I do have a greatest common factor 3 I can factor out. So if I factor out 3, be very careful here. 3 going to 3 is one term. Okay, so if the problem has two terms, that means in the parenthesis, I'm also going to have two terms. I cannot just ignore this 1 here. 3 going to 3 is 1, plus 3 going to 192, 3 going to 64 times y to the third. All right, 3 going to 192 64 times. So what was my 1 before it was cubed? This 1 is actually already cubed, which is still 1. So my 1 before it was cubed must be 1, plus my B, what was this 64y to the third before it was cubed? It must be 4y. So that's my A, that's my B. All right, then the formula says A squared, my A squared, which is 1. The next sign is minus, because these two signs got to be opposite. Minus my A times my B, which is still 4y, plus my B, which is 4y, whole thing squared, which is 16y squared. So all this is going to be my answer. All right. So just a quick 3 example on how to factor, sum, and difference of cube. So the next section, 13.5, we are going to put all the factoring problems together, okay, in one section, and I normally arrange them randomly, just to kind of help us to recognize what type of factoring problem they are, and factor accordingly. Okay, good exercise in 13.5 when it comes to putting all the factoring problem together. All right, that will conclude this lecture video on how to factor sum and difference of cubes. Thank you for watching.